So today we are starting in the Young's experiment in the terms of the wave front. In the terms of the wave front. Here we are considering one is your crest and other one is your throat. Now let us consider a monochromatic light. We are considering a monochromatic light. In this monochromatic light, we are considering one is throat. This is your throat. And other one is crust. Other one is crust. One is throat and other one is crust. When the monochromatic light which is made, here this monochromatic light either it is in a cylindrical shape or the spherical wavefront. Now when it is made to pass through the slit S1 and S2, when it is made to pass through the slit S1 and S2, how the formation will be there, how the wavefronts are produced, we have to see here. Now let us consider first there will be a crust, throat, and other there will be a crust. Okay. Now in the second one we are considering, again we are considering one is crust, this is your throat, and this we are considering as a crust. Here now the diagram is in this way. Now here how we are getting, we have to study. Now first point we are getting in this way, and second point we are getting here, and third one is here. Now when we are made to pass the wavefronts in the Young slit experiment, how we are getting? Here we are getting the superposition of the crust and crust, throat and throat. In the first case we are getting the superposition of the crust and crust, or throat and throat. Throat and throat. Here we are not getting any mix up. In the second case, here, the point is here. In the second case, what we are getting? We are getting the superposition of the crust and throat. Superposition of crust and throat. Or throat and crust. In the second condition, we are getting the superposition of the crust and throat. In the last, again we are getting the superposition of the crust and crust, or throat and the throat. Crust and crust, or throat and the throat. This we can study that how the wavefront is getting in the Young double slit experiment. In the Young double slit experiment, when the wavefront is made to pass, either it may be a spherical or the cylindrical. First we are getting crust or crust, or throat. When it is get mixed up, we are getting the crust and throat. Again we are getting the same crust and crust, and other one is your throat and throat. Now next we have to study the Young double slit experiment by using the interference. Now let us consider a rectangular slit. Let us consider a rectangular slit, and again one more slit. Now in this we are considering one is your S1 and other one is S2. The difference between this we are considering as a D. When this is made to fall on the screen, we are getting the dark fringes, bright fringes, dark fringes, and the bright fringes. Now let us consider a monochromatic light. Monochromatic light, yes, which is made to pass on the rectangular coil of the slit other one. That time we are considering the two sources S1 and S2 in a slit. Okay, here the difference S1 and S2 we are considering as a small d. When it is made to fall on the slit, we are getting in this way. Again, when it is made to fall on the rectangular coil, that time we are getting the fringes. Here we are getting the fringes. One is dark fringe and other one is bright fringes. We are getting as the dark fringe, bright fringe, and the dark fringe and the bright fringe. Now let us consider when we are considering the slit S which is made to fall on the rectangular coil, what will happen? We have to study here. We are getting the dark and the bright fringes. Now according to this, the intensity of the dark fringes is more. Dark fringe is more. Second one, bright fringe is less. Bright fringe is less. And in the third, at the center point, we are always getting the dark fringes. At the center, we are getting the dark fringes. At the point of the center, we are getting the dark fringes. And we also tell that it can also have the alternate dark and the bright fringes. And from this, we can tell that the width of the bright fringe. The width of the bright fringe is always equal to the dark fringe. Is always equal to the dark fringe. If you are considering the width of the bright fringe, it should be always equal to the width of the dark fringe. And from this we can tell that the intensity of the dark fringes is always 0. The intensity of the dark fringe is 0. If the intensity of the dark fringe is 0, and what about the bright fringe? The intensity of the bright fringe is same. The intensity of the bright fringe is always same. In the dark fringe we are considering the 0, and in the bright fringe we are considering it should be the same. The intensity should be the same. Now let us consider here expression for the interference free in the Young double slit experiment. Or just we have to derive the equation. Now let us consider the diagram. S1 and S2 are the two slits. S1 and S2 are the two slits. Q is the midpoint. Q is the midpoint. Next, theta is the angle. Dx is the path difference. Now d is the distance of the double slit. First we are considering here double slit experiment. And here it is the observation. D is the capital D is the distance between the double slit experiment and the observation slit. And other one, SP and S2P are the two wavefronts. S1P and S2P are the two wavefronts. Now next, here we are considering the X is a mean free path. Now let us consider here small d. It is the distance between the sources S1 and S2. Small d is the distance between the slit of the S1 and S2, and capital D is the distance between the double slit experiment and the observation experiment, and S1P and S2P are the two wavefronts, and Q is the midpoint. Now let us consider or draw SN perpendicular or draw S1N perpendicular to the S2P. S1N is perpendicular to the S2P. Next, we are considering the path difference, that is your delta x. Path difference delta x is equal to, we are considering S to n. The value of S to n. Sorry, S to n. S to n is equal to, we have taken S2P minus S1P. The value of S to n is equal to S2P minus S1P. Now, here we have taken the value of the S to n. Now let us consider the angle NS1 S2 is equal to the angle POQ is equal to the theta. From the triangle we are considering NS1 S2 sin theta is equal to delta x by d. Sin theta is equal to delta x by d from the diagram. Therefore, from the triangle again we are considering PQO. If we are considering PQO, we are getting the tan theta. Tan theta is equal to x by d. Now next, for the small value of the theta, we are considering for the small value of theta. For the small value of the theta, sin theta is equal to tan theta. From the equation 1 and 2. From the equation 1 and 2, we are considering delta x by d is equal to x by d. Delta x by d is equal to x by d. Therefore, delta x is equal to x into d by d. Delta x is the path difference. Now, just we have to find the value of the small x. We can take the value of the x as x is equal to, now let us consider x is equal to, or delta x into d is equal to x into d. or delta x into d by small d is equal to x. Therefore, x is equal to delta x into d by d. Delta x is the path difference, capital D is the distance between the double slit and the single slit, and small d is the slit between the S1, distance between the slit of the S1 and S2. In the same way, we have to consider here. Now for the end bright fringe, now we are considering for the end bright fringe. That time we have taken x is equal to xn and delta x is equal to n into lambda. Put this in equation 3. Put the values in equation 3. Therefore, in the case of the x, we are considering xn is equal to delta x means n into lambda into d by small d. Consider this as equation 4. This is for the n bright fringe. Now, in the same way, we are considering for the n plus 1 bright fringe. We are considering for the n plus 1 bright fringe. In this case, we are considering x is equal to xn plus 1 and delta x is equal to n plus 1 into lambda. Now put all this equation, put all the equation in the equation 3. We are getting xn plus 1 is equal to delta x means n plus 1 into lambda into d by small d. Consider this as equation 5. Now we are considering here one is your n bright fringe and other one is your n plus 1 bright fringe. Now from the equation we are considering 5 minus 4. Now consider the equation 5 minus 4. We are getting the equation as 5 minus 4. Therefore beta is equal to n plus 1 into lambda into d by small d minus n into lambda into d by d. Now this equation we are getting here, cancel all the terms which get cancelled, and we have to find here the value of the beta. Now in this condition we have taken here lambda d by d is the common term both the sides. Take it outside lambda d by d, and in the bracket the remaining term we are writing n plus 1 minus n, and n get cancelled. The remaining term beta is equal to lambda into d by d. Therefore, this is the expression for the interference of the fringe in the Young double slit experiment. Beta is equal to lambda d by d. This is the expression for the interference fringe in the Young double slit experiment. The diffraction of the light. Now to define the diffraction of the light, just we are telling the bending of the light. The bending of the light at the corner. At the corner is called the diffraction of the light. Diffraction of light means what? It is the bending of the light at the corner is called as diffraction of the light.